Okay, today we're going to start with a couple of questions from section 6.6 first, law of cosines and law of sines. So we're going to start with, on section 6.6, we're going to start with number 14. So if everybody looks at number 14 on page 521, so number 14, page 521. So we have that B is 60. And we have C is 30. And we have A, measure of angle A, is 70 degrees. Now, the first thing you want to do on this kind of a problem, because it says solve the problem, so solve a triangle. Solve means find all the stuff that you haven't found already. Solve the triangle. Is to make sure that your calculator, and if you have a calculator, you need to get that calculator, but make sure your calculator is in degrees mode, because we switch back and forth radians to degrees, and you don't want to get confused which one you're on. So 60, 30, and angle A. The other thing is we always draw a picture, and within this picture there's a certain way that we've learned how to draw it. A, B, and C, capital letters, are going to be the angles, and then lowercase a is opposite capital A, lowercase b is opposite capital B, and lowercase c is opposite capital C. So the lowercases stand for the length of the sides. So now we've got the situation where we're looking at this. So now we're going to label it. So 60 would be B, that would be a side, 60 units. And C is going to be 30. And this A is an angle, so we've got it inside, so this is 70 degrees. Now, we know that in order to find which one we use, law of sines or law of cosines, law of sines has to have an angle with a side opposite it. The law of cosines has to be an angle that's included between two sides. So you can see on this one, this 70 degrees is between the B and the C, right? So what we're going to find first is we're going to find A. So we're going to use our law of cosines. So we have A squared equals 30 squared plus 60 squared minus 2 times 30 times 60 cosine 70 degrees. Now, if you reverse these, that's okay. You could have put 60 squared plus 30 squared minus 2 times 60 times 30 cosine 70. So I would encourage you at this point to put parentheses here and parentheses here. That way you're keeping this all in one unit. So you're going to have 30 squared on your calculator plus 60 on your calculator minus parentheses 2 times 30 times 60 cosine 70 parentheses. Now once you get that answer is going to be A squared, so you have to take the square root of that answer. So you should end up with something that says A is approximately 57.1728. So that's our lowercase a. That's our length of our side then, right? So we're going to write this as 57 point, and let's go, 1728. So you could use law of cosines again, but in this case it's easier to use law of sines. So we're going to use law of sines next. So what did we say we had to have for law of sines? We had to have a side and an angle opposite it. So here we have 70. And the side opposite this angle, so those two go together. So we can find either B or C, it doesn't matter, so let's go ahead and find B next. So we're going to set it up as sine 70 degrees over 57.1728, that's supposed to be a 5, equals sine of B, because B is our angle, over 60. So now we have a proportion, and this proportion then we're going to cross product, cross multiply. So I get 60 sine 70 degrees equals 57.1728 sine of B, multiplying the cross multiply. But we're solving for B, so the next thing we're going to do is get this sine B by itself. So I divide, and I get 57.1728 on this side, and 57.1728 on this side. So these two cancel out. So now that gives me sine of b equals. Now again, you don't have to, but I would encourage you to put parentheses around your numerator. So you're going to put parentheses 60 sine 70 parentheses divide 57.1728. So we get sine of b is approximately 0.98616. Did everybody get that? Give everybody a chance to try that on your calculator. Now we're trying to find out what b is, so we're going to say b is approximately the inverse sine of 0.98616. So we do that on our calculator, and you get b is approximately 80.456 degrees. So we're okay with that. Now we potentially have a first quadrant and a second quadrant angle. So we're going to have first quadrant angle is the 80. So B1 is 80.456. And quadrant 2, we're going to take this and subtract from 180 to get our quadrant 2 angle. So I get 99.544. So now we're going to consider, like I said, the fact that we have two triangles. So if this is quadrant 1, we know we got a 70 for going to be our A. So 70 degrees is A. So to find my C, I've got A, and B. To find my C, then what do I have to do? Well, I take these two angles, add them together, and then subtract from 180, because we know all the angles of a triangle have to add to be 180. So I'm going to add the 80.456 and the 70 and subtract from 180. So we're going to write it as 180 minus parentheses 80.456 plus 70. And that's going to give us our C. So everybody get that a minute to try. So that gives me that angle C is approximately 29.544 on this side. And we're going to do the same thing on this side. 180 minus 99.544 plus 70. And that gives us that C is approximately 10.456. And again, those are all degrees, because we're talking about the angles. Now, so far then, we found two of the sides. We found C and B, and we found A. So I guess maybe we found everything we need then, right? So we said that lowercase a was 57.1728. Let's pull this down. And we now have B and we have C. So B would be here. And C would be here. That was first quadrant. And then on this one right here, B would be here. And C would be here. Okay, so that's number 14. All right, we're going to try another one. on that same section 6.6, and then after that we're going to go into our review. So the next one we're going to look at is problem number 44. So we're going to look at number 44 next. So number 44 is on what page? Let's see. Is on page 522. Okay, so you've got page 522, number 44. This is still section 6.6. Okay, so the question reads, two boats leave the same port at the same time. One travels at a speed of 30 miles per hour in the direction north 50 degrees east. The other travels at a speed 26 miles per hour in a direction south 70 degrees east. How far apart are the two boats after 1 hour? Okay, so the first thing we're going to do is draw a little compass. So this would be north, south, east, and west. All right, so the question says that two boats leave the same port at the same time. So this is going to be our port, so we're going to call that P. So right there would be our P for port. One travels at a speed of 30 miles per hour in the direction north 50 degrees east. So we've got north 50 degrees east. So that's a bearing, right? So the bearing is you're going to start at north and go towards east 50 degrees. Okay? So that's going to be a little bit more than half, right? From north to east. So we're going to put our line going in like this. So where's our 50 degrees? From north to east would be the 50 degrees. So we agree with that for the bearing. And then this first one says, leaves the same port at the same time, travels at a speed of 30. So this would be 30 miles per hour for this guy. All right. Then it says the other travels at a speed of 26 in the direction of south 70 degrees east. South 70 degrees east. Okay, so where would south 70 degrees east be? Well, we're going to go from south towards east again, so it's still going to be over here. So we're going to draw our line in. So this is our south to east would be our 70 degrees. Now it says that this one was going at a speed of 26 miles per hour. Then it says, how far apart are the two boats after 1 hour? Okay, so if this one's going 30 and this one's going 26 and they're both going miles per hour, then in 1 hour this one would be what? Have gone 30 miles, and this one would have gone 26 miles, right? Because they've only gone for 1 hour. They want to know how far apart they are. So we're looking for this distance from here to here. So let's call that something like x. Well, so what do we need? We need this angle inside here, because this would form a triangle, right? So how do we find this angle to get that angle that's between the two sides? Because if we have an angle that's included between the two sides, then we know we can use law of cosines. So if this is 50 degrees, and this is 70 degrees, and this is a straight line, well, we know a straight line is how many degrees? 180 degrees, right? So we're going to take the 180 degrees, and we're going to subtract the 50 plus the 70, right, to make this straight line. So we know that that puts our angle to be what? This would be 120 from 180 would give us 60 degrees. So we're going to call that angle P. Okay? So this is going to be 60. So now we can find x easily by using law of cosines. So we have x squared equals, and then again, it doesn't matter whether we say 30 or 26 first, because they were just talking about the sides. So 30 squared plus 26 squared minus 2 times 30 times 26 times cosine of our angle, which is 60. So now you're going to put that in your calculator and make sure you take the square root because we're looking for x. So x squared comes out to be something like 700 and something. And so x comes out to be 28.2134. But the problem says to round to the nearest whole number, so we have 28 miles. So again, the way we could tell we could use law of cosines is because we have two sides and an included angle. And we also need to remember from this problem how to use bearings. So these two things are what we call bearing. Sometimes they call it north-south bearing because you're going from north and south each time. Okay, so those are the two that we're going to do from section 6.6 right now. 6.6 has also got a key that's attached to Google Classroom so that you can check your answers that way too. The next thing we're going to do is we're going to look at the review for the Chapter 6 test. So I want everybody to get their spiral so you can put some stuff for Chapter 6 in your spiral. So we're just going to do like one from each section. So the first one, number 1, it tells us in this problem that we want to convert the angle in degrees to radians. Express your answer as a multiple of pi. So that means that they want you to put it in exact form. They don't want it as decimal approximation. So we're looking for exact form, not decimal approximation. So we learned that we're going to take 144, and if this is degrees, then we're trying to change it into radians. So I think I want to have a pi in my answer, right? So if I want a pi in my answer, then this is the one where I multiply by pi over 180. So if I'm going to multiply by pi over 180, we're going to see what can cancel between the 144 and the 180. So if we look at this one, we can divide by, I think it's 36, so you might check me out. So if I take 36 into 144, do I get 4? And 36 can go into here, 5. So you're just simplifying. Now, if you don't see the 36 to begin with, you could also see that 2 goes into both of them because they're both even. So this gives me my answer of 4 pi over 5. And that would be my radian measure. And that's the same way you're going to do the other two. Okay, the next one we're looking at is this one down here. You have negative 35 pi over 9. Now, when this one's converting angles from radians to degrees. So this time you want the pi to go away, right? So this time we're going to multiply by 180 over pi. Now be really careful on these not to lose the negative sign. But in this case, the pi's are going to cancel. Divide pi into the top and the bottom. And here we can see that 9 will also divide into here times 20. So now my final answer is going to be negative 35 times 20, which gives me negative 700 degrees. So this is the first one was converting degrees to radians. This one is converting radians to degrees. Okay, we're going to look at both of the next two. So this one says to find a positive angle less than 360 or 2 pi that is coterminal with the given angle. Now, I'm going to do both of these, but I want you to do it by this method instead of subtract, 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 because I could give you a really big degree number here. So we're going to start out the first step, step 1, is to take and divide 558 degrees by 360, because we're trying to find out how many times it's going around the circle, going around and going around and going around. Like I said, I could give you 1,000,000 something degrees. So that's why I want you to learn this method. So when I divide, it gives me 1.55. Now that 1.55 means I go around the circle one complete time for the 360, and then I have a partial one left over. So when I go, the next step I'm going to do is I'm going to subtract off the whole number parts. So you got this number on your calculator right now. So you're going to subtract 1, and that's going to give me 0.55. So I'm just looking for the portion that I've gone past the one complete rotation. Then I take this times 360 again, because this is the partial part of the circle, sort of like a percent, and that's going to give me 198 degrees. So that is a positive angle less than 360 degrees that's coterminal with this 558 degrees. Now, this one's not on there, but what if I asked you what the reference angle was? So reference angle can be interpreted from this 198. So where is 198 going to be on my unit circle? Well, let's draw a little unit circle. 198 we know is going to be past 180, but before 270. So to get my reference angle, I'm going back to the x-axis. So I'm looking for that little angle right in there. So that's going to be 198 minus 180, which would give you 18 degrees for the reference angle then, right? You're taking the 198 minus the 180 to bring you back to that little portion, that little pie shape there, which would give me 18 degrees. Okay? Second one is in radians form. So the first one was degrees. So this one now we're looking for something that's positive angle that's less than 2 pi. So we're taking the 10, dividing by the 3. We did this in chapter 5, right? So it goes into there 3 times 9, subtract, and get 1 and 3 and 1/3. Now this is 3 and 1/3 pi because it came from the 10 pi over 3, right? But each complete rotation this time, where we subtracted off the 1 here, that gave us 1 complete rotation. Well, down here we're going to subtract 2 pi to get 1 complete rotation, which would give me 1 and 1/3 pi, which again now is less than 2 pi, but we have to change it to improper fractions, so 3 plus 1 is 4 pi over 3. So that would be my coterminal. But now let's find the reference. So this is coterminal. And now we're looking for reference angle. So the reference angle on this one, we're going to have to put it on a unit circle again. So 4 pi over 3. This would be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 would be right here. So what would bring us back to the x-axis? Well, we can see that that's going to be pi over 3. So reference angle, coterminal. Okay? This next group is finding the length of an arc. Now, one of the things on this one, the formula is S equals R theta. That was the arc formula, right? But the thing we have to remember is theta always has to be in radians. So if they give it to us in degrees, we have to do conversion to get it into radians for the formula to work. The other thing we have to watch for is that a lot of times on these problems when they're doing arcs, instead of giving you the radius of the circle, what they give you is the diameter of the circle. So this R stands for radius. But if they give you the diameter is what? Twice the radius, right? It's all the way across the circle. So they've got an arc is what cut off by a central angle. So this is my S, this is my R, right? And here's my theta. So we want theta to be in radians, and we want S and R, we want R to be the radius instead of the diameter. So in my first one I have R is 40 inches and theta is 20 degrees. So S equals R is 40 is okay to use. And theta is 20, but that says 20 degrees, right? So to get degrees to radians, we have to go back to the first problem that we did, right? And we're going to multiply that by pi over 180. So these are all over 1, so put it in your calculator. I would put parentheses around the numerator, and then you're going to divide that by 180. And let's go, it says to 2 decimal places. So we have approximately 13.96 inches. So give everybody a chance to see if they get 13.96 inches. Okay? All right, the next one we're going to do is number 7. Okay, number 7 says, solve the problem. A pickup truck is fitted with new tires, which have a radius of 21.5 inches. How fast will the pickup truck be moving when the wheels are rotating at 250 revolutions per minute? Express the answer in miles per hour rounded to the nearest whole number. I like this kind of a problem because we do a lot of fixing, making changes. So let's watch what we're doing now. This one is a linear speed problem. So we have V equals R omega, where V is linear speed and R is the radius. And the omega is a Greek letter that we use for, in this case, we're using it for angular speed. So linear speed is like miles per hour, feet per second. Angular speed is like rotations per minute or something like that, or revolutions per hour, that kind of thing. So in our problem, we're going to find the linear speed, it says, and it says that it has a radius of 21.5 inches. So we have 21.5. Now in this case, we're going to put the inches in the problem, times the angular speed, which we have is 250 revolutions per minute. So we're going to write 250 revolutions per 1 minute. And over here we're going to put this over 1 because everything's going to be in a fraction as we go across. Now a lot of people, what they do is they just start multiplying stuff on this kind of a problem. But what I want you to do is we're going to totally get it set up in an equation first, and then we're going to put them together. So revolutions, so that gives us our radius times angular speed. So you'd think we were done. But what it asks us to put our answer in terms of miles per hour. So we have to convert the inches into miles and convert the minutes into hours, and the revolutions we got to get rid of, right? So we've got to reconcile our units. So what do we do first? Well, it doesn't matter necessarily, we just pick one. So if we pick the minutes, if I want to change minutes to hours, then I know how many minutes is in 1 hour is 60 minutes is 1 hour. Also, I want the minutes to cancel out. So if the minutes is in the denominator, then I need to put the minutes in the numerator. So I'm going to put 60 minutes is 1 hour. Now, the reason why I can multiply by something like this is that 60 minutes and 1 hour are equal to the same thing, right? So this is just like multiplying by 1. All right, what else do we have to get rid of? We have to get rid of inches. Well, I wouldn't jump right from inches to miles because we don't know that in our heads. But what we do know is that there's 12 inches in a foot. So is inches going to be in the numerator or the denominator? Well, we want inches to cancel out, so we want that to be in the bottom. So we're going to write 1 foot is 12 inches. Okay, again, that's like multiplying by 1. So now we have to change the feet into our miles, right? So we want miles next. So if we're changing feet into miles, then how do we know? We know 5,280 feet is a mile, right? So where would feet be? Feet's going to be in the denominator, right? So we have 1 mile over 5,280 feet. So we're almost there. We still have to get rid of the revolutions, right? So we're going to say 1 revolution, 1 complete revolution is what? 2 pi, right? So we got 2 pi, 1 revolution. So revolution had to be in the bottom because over here it was in the numerator, so we had to have it in the denominator. So now let's start canceling out and see if we've got miles per hour. So we have revolutions is going to cancel with revolutions. We have feet with feet. We have minutes with minutes. And we have inches with inches. So now we're down to what? Miles per hour. There we go. So now all we have to do is put it in our calculator. So we're going to start with left parentheses across the numerator, and you're going to do left parentheses, right parentheses across the denominator. So you got your calculators. Left parentheses 21.5 times 250 times 60 times 2 times pi, right parentheses, then divide, left parentheses 12 times 5,280 parentheses. So you should get your linear speed as approximately, and it says express your answer to the nearest whole number. So we should get 32 miles per hour. Does everybody agree with that? All right, we're going to jump down to number 9. Okay, down to number 9 on the review. It says use the Pythagorean theorem to find the length of the missing sides, then find the indicated trig functions of the given angle. Give an exact answer with a rational denominator. Now on this one it asks for tangent, cosine, tangent, and sine, but we're going to go ahead and find all 6 of them. So we have this triangle, maybe a little hard to see, so we'll see if we can draw the triangle a little better. Okay, so that's a little better. That's supposed to be a 7. Okay, so we're going to use Pythagorean theorem. It even tells you in the problem. Use Pythagorean theorem to find the length of the missing side. So this is our missing side over here, C. So how do I find C? Pythagorean theorem says square the legs, add them together, and that's going to be the hypotenuse squared. So we're going to have 7 squared plus 6 squared equals C squared. 49 plus 36 gives me, what, 85 C squared. Then we're going to take the square root on both sides. So this gives me C is plus and minus the square root of 85. Now, what do we know about square root of 85? Well, square root of 85, we know we can't use minus because why? Because if we use minus, it's talking about the length of a side, right? So we know that our C is going to be the positive square root of 85. Now our theta is down here this time, right? So when we do our SOHCAHTOA, we're going to have our sine of theta. This time opposite is going to be straight up above, right? Because opposite is straight across from. And hypotenuse is our square root of 85. So we get sine equals 7 over square root of 85. But by now we know if I take square root of 85 in the top and the bottom, I'm going to get 7 square roots of 85 over 85. So there's my sine. That's the SO part. Then we have the CA. The CA is adjacent over hypotenuse, so adjacent is next to but not the hypotenuse. So this is going to be 6 over, so cosine theta equals 6 over square root of 85. But again, we're going to rationalize the denominator, so we get 6 square roots of 85 over 85. And then tangent is the TOA. So tangent of theta, we said, was going to be opposite, which is the 7, over adjacent, which is the 6. Now, like I said, this one only asks for sine, cosine, and tangent, but we're going to go ahead and do the other three because they're going to be pretty straightforward. Because all I have to do, since they're called reciprocal function, is decide which ones they're the reciprocals of. So I'm going to do cosecant first. Cosecant is the reciprocal of the sine, so if I go back to this step right here and do reciprocal of the sine, I'm going to get square root of 85 over 7. And then if I do secant, secant is the reciprocal of the cosine. So reciprocal of the cosine would be here in the middle, would be square root of 85 over 6. And then the last one is cotangent. Cotangent is reciprocal of tangent, so we'd have 6 over 7. So like I said, once you get the first three using SOHCAHTOA, then you just have the other three by using the reciprocals. Okay, next one, it's on the next page. We're just going to do a couple of these because you guys did these in chapter 5 as well. Now, you can use these 45, 45, 90 or 30, 60, 90 triangles if you want. I think most of you will probably do unit circle to make it easier. The first one is secant of 30 degrees. So we're going to use unit circle. Here's 30 degrees. We know that the secant is the reciprocal of the cosine. So at 30 degrees, since this is the long and this is the short, we know that the cosine is going to be square root of 3 over 2 for a cosine. But we want to reciprocal it, so we're going to flip it over. We're going to have 2 over square roots of 3. Now we talked about the fact that by now you should know how to rationalize the denominator. So square root of 3 over square root of 3 gives me 2 square roots of 3 over 3. So let's jump down and do number 13. Number 13 is tangent 3 pi over 2. So again, if I go to my unit circle, 3 pi over 2 is going to be down here. The ordered pair is 0, negative 1. Now we know tangent is sine over cosine. So sine over cosine is going to be y over x, so I get negative 1 over 0. Now this is where we have to watch. Can I have negative 1 over 0, or can I have 0 over negative 1? So a lot of people have trouble. 0 over negative 1, or negative 1 over 0. So which one of those is okay and which one of those is not okay? Okay, so this one equals 0. So that one's okay. This one is undefined. Okay, because we can't divide by 0. So make sure you're careful with those two. So in this case, our answer would be undefined. All right, so let's go down. Let's try the next one, cosine of 5 pi over 4. So cosine of 5 pi over 4, we know is going to be in what quadrant? Third quadrant, good. So we know that that's going to be cosine is negative. So we're going to have negative square root of 2 over 2. Now, like I said, you can use the right triangles up at the top if you want to, and that's also okay. Now, on number 18, we're not going to do number 18, but I want to point out the fact that on number 18, it says you're supposed to find it with using your calculator this time. It says use the calculator to find the values of the trig functions to 4 decimal places. Make sure on this one, since it does not say degrees, then it means radians. So this has to be, your calculator has to be in radians mode. The other thing is cosine's on your calculator, so that's easy enough for you to do. But the the cosecant is not on there, right? So the cosecant, we're going to change that to 1 over the sine of 4. And then put that in your calculator. Okay, so everybody got those two written down? Now, you have to remember you got to change it back now so that you don't get confused. Make sure you change it back. Okay, a radio transmission tower is 210 feet tall. How long should a guy wire be to be attached to 8 feet from the top and is to make an angle of 25 degrees with the ground? Give your answer to the nearest tenth of a foot. Now, this is the problem with this kind of a problem is a lot of times people don't understand what it's talking about when it's talking about a guy wire. A radio transmission tower is 210 feet tall. How long should a guy wire be to be attached 8 feet from the top and to make an angle of 25 with the ground? So the thing that you got to remember is what they're talking about is if you go down on Broadway Extension there by Edmond, there's those those towers with the red lights. All those diagonal lines that are attached are called guy wires. So we have this tower. And here's the ground. And it says that the tower itself is 210 feet tall. So this whole thing from here to here is 210 feet. Then it says that you want to attach the guide wire 8 feet from the top, and it's to make an angle of 25 degrees with the ground. So you're attaching it here. It's going to the ground. Now, it says, how long should the guide wire be 8 feet from the top? Well, if this is 8 feet, this short part right here, and the whole thing is 210, then we know this is going to be how many feet? This is going to be 202, right, from here to here. The next thing that we want to know about is the fact that it says that it makes 25 degrees with the ground. So what does 25 degrees with the ground mean? Well, we're talking about this one because it's from the ground, right? So we have 25 degrees. So the question says, how long should the guy wire be? So there's our x, it's going to be on that side. Now, when you do this problem, got to make sure your calculator's in degrees mode again because you just changed it before into radians. So we want to make sure we're in degrees. And now we've got a right triangle. So we're back to right triangle trig, which says SOHCAHTOA, right? So we have SOHCAHTOA. So we're going to look and see what's given to us in our triangle. If this is our angle, the 202 is my what? That's my opposite, right? So that would be opposite. And the x is my longest side opposite 9 degrees, so this is going to be my hypotenuse. So now you have an opposite and you have a hypotenuse, so we know that's going to be sine. So we say sine of 25 degrees equals 202 over x, right? Now we put this over 1 and we now have a proportion so we can cross product. So we cross product and we get x sine 25 degrees equals 202. But we're solving for x and this is multiplied so we can divide both sides by sine 25 degrees. So this cancels out and whatever this comes out to be then should be my answer. So calculator ready form says to the nearest tenth of a foot. So you get x is approximately 478.0 feet. We got to have the 0.0 because it says we want to know the nearest tenth of a foot. Okay, we're going to jump down to number 23 because we did one already like 21 and 22. So we're going to go down to 23. Now this one again was from last chapter as well, so we're going to equals y. This one equals y, so we're going to set up to get rid of the -1, so we're changing it from inverse function. So I'm going to have sine of y equals square root of 3 over 2. So sine of y equals square root of 3 over 2. We know that y is restricted for inverse function to be from pi over 2 to negative pi over 2. Since sine is positive, we know we're going to be in quadrant 1 because sine is negative in quadrant 4. So we're looking for sine to square root of 3 over 2. So we look at our unit circle. We know that the sine is going to be square root of 3 over 2 at pi over 3. Same kind of idea on this one, except the only difference in it is your restriction is from 0 to pi. So that's going to place us in what quadrant? Quadrant 2. So you can finish that one from there. Okay, the next one we're going to look at is number 30. No, I'm sorry, number 26. Oops, that's 27. Let's go down one more. Okay, next one we're doing is number 26. This one is solve the triangle again. All right, so solve the triangle. We know that we have a 35-degree angle and a 105 degrees, and we know that the side B is 6. So what we're going to have to do next is we're going to calculate to see if we can find an angle. Well, if I know two of the angles, then I know they all add up to be 180. So I've got 180 minus 35 plus 105. All these are degrees. So 35 plus 105 subtracted from 180 should give us 40 degrees. And that's going to be our measure of angle C. So that's the first thing we're looking for. So that becomes 40 over here. So now we have a side and an angle opposite it. We've got the 35 and we've got the 6 that are opposite each other. So then we could find either side A or side C, either one, whichever one we want to find. So let's find side A first. So I'm doing sine of 40 degrees over C. Whoops, I said I was going to do A first, didn't I? All right, we'll do C first because that's what I started. Sine of 40 degrees over C equals then our one that we know, sine of 35 over 6. Okay? Now if we wanted to find A, we do the same thing. Sine of A, which is 105, over A equals again sine of 35 over 6. So we just cross product again. We get 6 sine 40 degrees equals C sine 35. And then we divide by sine 35 on both sides. Now make sure your calculator is in degrees mode. And then I would put parentheses around the numerator for that one. You're going to do the same thing on this side. Give everybody a chance to catch up to that point and see what you get for both of those. So you're going to find C and you're going to find A. And let's see if they told us what to do to, no. So let's go to the nearest tenth. Okay, so we'll get A to be 10.1, and we get C to be 6.7. Is that what everybody got? Okay, so now we're going to jump down to number 29. Okay, number 29, the area of a triangle having the given measurements, round to the nearest square units. So we have to draw our own triangle on this one. Now remember, A, B, C, B is opposite B, A is opposite A, and C is opposite C. So we have those measurements first. It doesn't have to be drawn to scale, but where we place the actual A, B, and C does matter. So it says we've got angle A is 20 degrees, so this is 20 degrees. And we've got side B is 13, so 13 meters there, and side C is 10. So do we have a formula that we can use for area of a triangle that has an angle between two sides included? Yes, we do. We just learned it, right? So we've got area equals 1/2 BC sine A. So we're going to just plug straight in. So area equals 1/2 times 13 times 10 times sine of 20 degrees. And we just put it in our calculator, and we get our area to be what? It says to the nearest square unit. So we've got, give everybody a chance to plug it in for a second. So area is approximately 22 square meters. Is everybody okay with those two? All right, we're just going to do number 30, which is right below here. It says the surveyor standing 64 meters from the base of a building measures the angle to the top of the building and finds it to be 39 degrees. The surveyor then measures the angle to the top of the radio tower on the building and then finds it to be 48 degrees. How tall is the tower? The radio tower. Okay, so we have a building, and we have the ground, and we have a radio tower on top of the building. So here's my building, and there's my radio tower. So he says he's standing 64 meters from the base of the building, and he measures those two angles. So here he's out here somewhere, and he's measuring this angle, and he's measuring this angle. So the first one, it says, standing 64 meters from the base of the building, the angle to the top of the, says the base of the building measures the angle to the top of the building and finds it to be 39 degrees. So this one right here would be 39 degrees. And then he measures the angle to the top of the radio tower and finds it to be 48. So from here to here is my 48. So the whole distance across. So how would we find those two things? Well, we're looking at two triangles. We're looking at this bottom triangle and then the one that has the whole thing on it. So we're looking at two triangles. So what do we know about anything else? Well, we're going to name this to be some letter. So let's call this Y. And from here to here, let's call it P. So we also know one of the things that we haven't labeled here, from his distance from the building. So this is over here on this side is 64 meters. So now what do we have? If we look at SOHCAHTOA, because we're in a right triangle, if this is my angle, then I have opposite over adjacent, right? I have tangent. So I've got tangent of 39 degrees. So we're looking at this one first, is opposite over adjacent for TOA, right? Which would be Y over 64, right? And then on the other one, we're going to have tangent of 48 degrees. And it's this tallest side, right? So opposite over adjacent for it is going to be what? P over 64. So we get tangent because it's opposite over adjacent, right? We don't know anything about the hypotenuse. Put this over 1, put this over 1 and cross product. What do I get? Y equals 64 tangent 39. Again, make sure you're in degrees mode. And P equals 64 tangent 48 degrees. So we get our two answers. So this one comes out to be 51.826. And this P comes out to be 71.079. So we subtract those two and we get the length of the tower to be 19.253 meters. Does it say how many? It says how tall to the nearest anything? No. So I'll try to make sure that I'm telling the test how tall or what to round to. Okay, the next one we look at is number 33. It's talking about the area using Heron's formula. So Heron's formula is the one where the semi-perimeter, S equals 1/2 A plus B plus C, and the area is equal to the square root of S times S minus A, S minus B, S minus C. So there's my formula for Heron's formula to find the area. Now this is when we find the area for given all three sides. So here they give us the sides A, B, and C. So we can draw a triangle, or on this case we probably don't necessarily need one because it gives you A, B, and C, right? So the first thing we're going to find is the semi-perimeter, half of the distance around it. So we have 10 plus 11 plus 15. So we calculated in our calculator, 10 plus 11 plus 15 is 36. Half of 36 would be 18, right? So our area is going to be the square root of S, which is 18, 18 minus A, which was 10, 18 minus B, which was 11, 18 minus C, which was 15. So 18 minus 10, 18 minus 11, 18 minus 15. So we get the square root of 18 times 8 times 7 times 3, which gives me the square root of, I guess we don't really care about that, we just care about what it is, right? So square root of all those things multiplied gives you the area of 54.990, but this one does say to the nearest square unit, so this 9 would make it to be 55, and it's going to be square yards, right? Now number 34 is going to do the same kind of thing, except they come to the end, they say how many cans of paint. So you're going to divide that when you get how many the square meters is, and then divide that by 70. Okay, so the answers are all on the back page. So this is all the answers. You can check yourself with the back page of the key. If you have any questions on any of the other ones, please let me know. Thank you very much.